Hello everybody and welcome to a new session. Today we are talking about data visualization literacy. This is going to be a part of this class in creating dashboards, and we are going to be discussing key elements in the concept of data visualization and what the people need to know and what we need to know about the people when doing data visualization. Then the learning objectives for today is to evaluate the factors that we need to consider in representing health data in visual fashion. And we are going to navigate towards different frameworks or theories that are going to help us to understand and consider when we want to represent data, what the people is expecting or what we need to anticipate. Then a big question again, and we keep asking is, why do we need to understand data visualizations? And understanding the visual thing is important now, because a lot of representation today is visual, and as they say, an image conveys more information than text. And also we need to understand data visualizations, because every single day they are more popular and important, given that the amount of data that is available is increasing exponentially. Remember that we are almost doubling the data that we create in healthcare every 63 days. Then there is no way of absorbing all that data, and we need to have practical elements and tools that allow people to understand what is going on, explore that data, extract that data in a way that is useful, be able to have the meaning of what is going on, and be able to represent the findings. And if we look government, institutions, news, everybody is using data visualization techniques to try to deliver information stories. And definitely visualizations are persuasive and attractive interfaces. And if we pay attention to this persuasive, it's really important to think that with the visualization we can change people's behavior. Then we can have a positive effect or we can have a negative effect. And we need to be aware of that in order to understand how we can achieve one or other intention. Then if we think about this, that an individual ability to read, comprehend, and interpret data is going to influence the task and the way that they communicate. And that's the reason why when we talk about visual literacy, or talking about this is an important as talking about people knowing how to read or how they comprehend the text. So nowadays we have the mobile devices, we have the internet, we have tablets, so we have this visual information that basically is one of those skills that we need to help people to develop, and we need to be aware where the challenges are. Then if we step a little bit back and we try to define literacy and look into the dictionary, then literacy is just the ability to read and write, no? And that's a basic skill that we expect in nowadays from human beings. But when we are talking about the information era, maybe we need to start rethinking what are the basic skills and what are the literacy skills, and start talking about information literacy, and now maybe talking about data visualization literacy. Why? Because the way that we use or me use data is going to have a profound impact in our lives. And I have been telling you that we can be persuasive in the way that we present data and in the way that we present visualization, and then we can have positive or negative impacts in that way that the people behave. And we have more and more data, duplicating data, growing exponentially, and government organizations, everybody is using data to try to make decisions. And at the end, this is trying to make sense of the world. Then definitely one of the main ways people access data is through visualization. And a lot of people feel like they don't have the skills, knowledge, or the make sense of this visualization. And actually, some of you that participated in the interactive session last week were aware of this effect. Hey, I struggle with this type of visualization. Sometimes I cannot understand that. And we are talking about highly educated individuals, and sometimes we pretend that people with the proper skills try to understand that. Then we need to really target the population and understand the level of literacy and what is going to work better. And as we talk about, hey, when we are talking to the public, we have a reading level of 5th grade, 7th grade, you name it, depending of the aims. Maybe we need to start having that references in the visualization. Hey, this is going to be a 3rd level visualization, a 5th grade visualization, a college visualization, you name it. And if we don't have those proper representation, then there are some people that is going to be left out about the data, about the things that we are doing. Then going back, yes, we said that the first level is that textual literacy, and it's basically understanding, using, reflecting, and engaging with written text. And at the end, we want to achieve one goal, develop one knowledge, and potentially participate on society. And that's one of those basic literacy that we want. And also about basic literacy that we want in the people is the mathematical literacy, that is also known as numeracy. And it's the understanding of the real number line, understanding of time, understanding of measurements, and some kind of estimation. And then this is going to help the people understand ratios. That is one of the most difficult things. Proportions, showing people proportions. We are not that rational as we think. We are really feeling driven, but we try to make people understand what is the concept of a portion, or a fraction, proportions, percentage, and probabilities. And this is challenging in general population. And at the end, mathematical literacy is that capability or capacity that individuals have to formulate, employ, and interpret mathematics in various of contexts. Sometimes we are limited to the basic subtraction and addition, but there are people struggling with that. And now we are pouring data, and we are creating visual information. And now the theory talk about there is a visual literacy. And the visual literacy is that group of skills that enable an individual to understand and use visuals when we want to communicate intentionally with others. There is a whole research. Why memes are so important in nowadays? Those are visual messages that are related with the mood, and they go straight away to our limbic system, and they have easy recordation. They activate our memory, and they convey a lot of information, and sometimes using jokes, or sometimes using other techniques that just move our our mood, then we can change that behavior. And also visual literacy can be defined as discriminate and interpret visible actions, objects, and symbols. They can be natural, man-made, that we encounter in the environment. And as you see, these definitions are not that new. They're relatively old because people has been discussing the visual system for a while. Then now what is data visualization or visualization literacy? Then it's not just to be able to understand those visual cues, but is defined as the ability to confidently use and give data visualization in order to translate questions specifying the data domain into some queries in the visual domain, or to interpret visual patterns and be able to identify those patterns as properties of that data. Other authors has defined this as the ability and skill to read and interpret visually represented data and to extract the information from that visualization or that representation. At the end, the visual literacy is an ability or skill to read, interpret visual presented data in and to extract information from that data. But we need to have into account two important aspects of literacy, because literacy always have two sides: the side of consumption and the side of production. And in that regard, then we are going to have two different levels of literacy. When we are talking in the domain of consumption, is that user that is trying to make meaning of that pattern that is presented, that trend, that correlation, that data that is visually represented. But when we are in the point of view of production, is that ability to use well-established data visualization tools in order to communicate effectively, efficiently, and in a confident manner. Then today we are trying to focus our attention in production. What are those key elements when we want to think in production? But in order to be able to produce something, we need to anticipate how it's going to be consumed. And even though we are talking about production, we need to be thinking about who is the user and who is going to be consuming that element. Then basically today is a perspective or a take in a paper written in 2016 that is investigating aspects of data visualization literacy using some information visualizations. And the paper is available in our material. It's not mandatory to read this paper, but I really recommend you to reference that. And this is the take in that perspective, and I think the authors has done a really good job in extracting all these basic elements and giving us an approach. Then if we want to make meaning of patterns, then for example, this is a picture of what was going on September 19, 2021. This is basically 1 year ago with COVID. And we can see how the hotspots were there and how things were behaving in the world. And there were some kind of disparities out there. And then it could be concern, but would say, hey, but we are talking about total cases. And it's not the same when we are talking of the biggest countries in the world, and it's not fair, the comparison. Maybe was the time to start correcting the numbers by the population, and instead of presenting total cases, we need to start presenting ratios, because the absolute numbers are really good to follow how fast disease or a phenomenon is spreading, but this is not the stage of talking about the spread, but now what is the general impact. And as you see, we can create some biases in the way that we present the data. I'm not saying that United States is not in bad shape, but maybe we are not being totally true in the way of present the data, because yes, absolute numbers, when we have a cumulative population that is different from the rest of the country, then we are going to expect more people. Maybe then we need to do those corrections. This is the same time frame, and we can see different dynamics, what was going on in the world. These are number of cases per day, and as I said, the number of cases per day is really useful to looking how fast something is being spread. But when you want to compare the prevalence or the amount of disease that you are having in your population, maybe a ratio is better. And this is also distribution of number of cases by continent. Again, not all continents have the same population. Not all continents have the same quality of information system. And that's then we start thinking now, we have a discussion about stack graphs, and okay, these are a number of cases, these are absolute numbers, then okay, we can have an interpretation that 1/3 in Asia, 1/3 in America, 1/3 in Europe, Oceania is imperceptible, and like a 10 or something in Africa. And we can see more or less the distributions, and some place in moments where Asia was contributing most of the cases. But again, what is the message that we want to convey, no? And here we have the same data represented in two ways, and both are stack areas. This is a stack bar by percentage, and this is a stack area by absolute numbers that is kind of normalized in the middle. Then we can just see the distribution. This is the hourglass or the violin, or this representation that we have a reference point in the middle, and we just split the magnitudes evenly across that middle line, and it allows to see this peak. That was the peak of April 15 in 2020. And that was the origin of the epidemic. And we can see here, interestingly, how Europe was disproportionately affected at the beginning, and how things started to change in America, and then when things started to change in Latin America, and then here just assume into what's going on in Asia. And that correlates with what happened with India, and then we can see the different behaviors like Mexico, Latin America, rest of Latin America, and Brazil. They were contributing a lot of average daily deaths. But if we don't understand really how the people use this data, maybe the message that we want to transfer is not going to be that easy. And this is the same data up to today. And now we can see a different story. That first first shot was around here, where we were experiencing the second wave. But now we can see historically that actually the peak of the pandemic was last year. We have in a single year 1, 2, 3, and 4 waves with a tendency, and again a spike. We are not seeing the 4, but we are seeing the second wave of the year around here that maybe maps with this, and perhaps this allows us to see, okay, there is a tendency that the graph I was pointing, then we can see this is the first peak, the second peak, but actually in 21, 1, 2, 3, and 4 peaks, 2022, 1 and 2. This one is similar to this one is kind of this one, and we cannot see the ones on between. But what I was saying is we can see that this started, went up, and now it has a tendency of going down. Are we going to close this? We don't know yet, but kind of we expected that the tendency is going to be in that direction, and now we can start doing some predictions, and kind of globally things are starting to compress. And then yes, but how to interpret really this graph, this complex graph, can be challenging sometimes for the people. Or this other one, these are the excess of death. And actually there is something that is interesting, because this number of deaths per week for all cases 2020, actually if you see this is 2020 and 21, but still is a little bit confusing, and compared with recent years. And that was the thing that was concerning everybody, because the excess of death, the only way to explain that was because we were having that pandemic, and we can see how there were countries that were more affected than other ones in that excess of rate, and it has kind of different behavior. But we see those double peaks most of the time. We can start looking into those patterns that are kind of consistent, with some skew on time, because it could be reporting, it could be related with closing borders, it could be related with different things, but it's telling different stories. And this is an example of one of the questions that we had about the multiple singles, or just the multiple small multiples that are small charts that are reflecting the same data, but with a different variable, that in this case the variable is the country. Or we can have this bubble graph where we see, okay, high and upper middle income countries are ahead on vaccination. This is showing vaccination total doses administered per 100 residents compared with the GDP per capita. But in these graphs, then, okay, we see, yes, that it seems to be a tendency. The more that you earn, the better you are doing. Something that you need to take into account, for example, in your literacy, is this scale is a logarithmic scale. This represents tenfold the income of the countries that are here are 10 times the income here, and these are 10 times the income here. Then it means that this is 100 times them come here, and a lot of times compared to here. And then we are wondering, oh, who are these guys that are up here? Yes, they are small countries. We can see that, but they are having a lot of vaccines per people. But sometimes if we don't have that in the label and we don't have the interactivity, knowing who they are is difficult, or extracting that data is difficult. Then it's when we need to support our data with new representations. And here we know who those 5 are. They are Cuba, Chile, Brunei, Vietnam, and Taiwan. We see that they have 2.5 to 3 doses per person in those countries. That's an interesting achievement, no? And then we can hypothesize the reasons for that, but that's part of the story and how we interpret the data. Then definitely the topics in visualization literacy is gaining a lot of recognition within the information visualization community. But the question is, again, why we can perceive images faster than writing, and how the brain gets information. And the quick answer for this is we are visual subjects, and all information that comes through the eyes are going to be processed like pictures. But when you are looking into text, you are not looking into individual letters. You are looking into those lines, and then that's a graph representation that you need to match and do a lot of processing, because you need to link the lines, and then those lines you need to map them to an image. And for example, if I say you table, for sure the image, or you read table, you are not putting TABLE in your brain. That activates in your brain is the own image of your table, but your table is not my table, and it's not the table of the other classmates. But the thing is, when we have visual simplicity, it's going to be easier to comprehend. Or think about when we are facing extraneous languages that we are not familiar with the way that is written, we are not going to have comprehension. I cannot read Japanese, I cannot read Chinese, I cannot read Arabic. They are using a different text representation. And even though we think that people can comprehend graphs in the same way, maybe not, because there are different human factors, like in which direction time goes, or how they understand the word, or what the color meaning has, can vary the meaning of the graph. But in general, there are more consensus, because we have these big metaphors about the containers, for example, then something that is fuller is better than something that is emptier. That is bad. And we have this kind of metaphors that we bring from the world that are in that positive. Green it's something that is growing, then it's something that we associate with positive things. Blood is red, and sometimes red is quite often is associated with negative things, because if you are bleeding, maybe it's not good. And in that sense is how color is a remarkable communication tool that definitely has a big role in design. But we need to understand that color can elevate a design and can apply emphasis where it needs to be needed, but we need to be also careful because color can create confusion. And remember that we need to be aware of people that is, for example, colorblind. And some of those representations using color, we need to be aware of that. But the most important thing is contrast is a key factor. Then the background needs to be in some way contrasting the content, and then create that. I posted also a conference from Stephen Few where he goes through a lot of techniques and interesting exercises about graphs and tables and all these human factors. But he is the one that definitely insists in we need to help people and be aware of levels of literacy or the ability to think and communicate in words, both spoken and written. We need to think about numeracy, how people think and communicate in numbers, and we need to think in graphacy or visualization and the ability to think and communicate with images. And he has really interesting insights. But when we review the research, we know that participants have significant limitations in naming and interpreting visualization and particular tasks. There are significant differences between novices and experts when they are reading and interpreting visualizations. And previous research has tried to understand how users with no specific training create visualization from scratch. Then looking into simplicity, specificity, and dynamicity are the main challenges when we want to help people create visualizations, even if they're not well trained. But in order to have a formal approach, then literature is presenting us with different frameworks. And one of the frameworks that we can look into is the Data Visualization Literacy Framework, or DVL. And this framework basically tells us that visualizations can be classified by the needs of the user, the type of data that we want to visualize, or the scale that we already introduced that concept, the type of transformations that we use or the analysis that we conduct in that data. And this framework differs a little bit from the previous concept that analysis and data transformations are separate concepts. They are just bringing them together. And how we map those transformations into visualization and how we use symbols and variables to represent how the graphic has symbols and the graphic has variables, and we are able to represent that data in this context. And what are the interaction techniques that we are using in order to extract or what are the tasks that we are performing in the context in order to answer to those needs and close the cycle. Then let's start thinking or talking about the insights or the needs. Then multiple authors have identified multiple needs, and these are the what literature has called the basic task, the basic task types, or the primitives task that we conduct. Then Burton was talking about selection, that we select some order, association, and quantity. Few talks about ranking, distribution, nominal comparison, deviation, time series, geospatial, pair-to-whole, and correlation. Geo, that is other author, then they have patterns over time, proportions, relationships, difference, and spatial relationships. Word talks about identify, locate, distinguish, categorize, cluster, rank, compare, associate, and correlate. Monster talks about analyze, search, and query, or listing, discovery, annotate, identify, and compare. Fisher and Mayer talks about finding values or reading values, characterizing distributions, and identifying trends. As you say, the basic tasks of the primitives can have different names, and there are a lot of variability in the literature about what are the needs of people. And then when we are saying what tasks we are going to be performing, then we can summarize them in some way, like we can categorize or cluster data, or that's some of the needs. Okay, what are the groups? How can I group this data set, or how can I present the data in some level, in some kind of groups? We can also have the possibility of order, rank, and sort, as I presented you with the data of vaccination, no? Because we could see the clusters and the tendency or the trend. That is one of the other insights in the relationship of the GDP and the vaccination. But when we have the rank or the sort of the absolute numbers and the bars, then we have a different picture. We also look into the distributions, and we saw how things are dynamic, and how we observe different peaks or waves of the pandemic, and we can see how things are happening, or the excess of death. And we can also identify outliers. As I presented in the graph, we saw that Cuba was really outside of all the tendency. We can create comparisons, and we made some of them when we were using that stack bar of the different continents, and see how things were just facing from one part of the world to another one. We can have geospatial needs. We introduced that already in the previous class, and we have seen some maps that are going to show us hot spots or areas of interest. We can have compositions that we have the narrative, and we have the different elements in order to tell story, and we can have correlations and relationships or needs to do that. The second element then into the framework is to understand the data scale. And when we talk about variables, and we know that variables are going to have different scales. They can be qualitative or they can be quantitative. When they are quantitative, they can be ratio, they can be interval, and sometimes they can be ordinal. And when they are qualitative, they are going to be ordinal, nominal, or we can use some intervals to describe, we can use some qualitative intervals to describe some quantitative elements. And that's really important to understand. Why? Because as you see, when we have discrete numbers, when you have a ratio, we can do a lot of logical and math operations. And we can do a lot of measurements. And it has more detail. But sometimes we cannot obtain that. We are having aggregated data by intervals. Then of course we are going to be limited in some of the operations. But we can preserve some of the other activities. And in the ordinal, then we are a little bit more restricted in the operations that we can do, and the most restricted one is going to be the nominal. That's perhaps the reason why we are so thirsty of having individual data and sometimes hesitant of having aggregated data. But the reality is not always we can have the individual observations. And then we need to be able to tell stories with what is available for us. When we think about the scales, those nominal data, the job type, uh, the name of the country, they have no ranking, but they can support those operations that we were saying, oh, are we equal or are we different? No. When we have ordinal data, there are some ranking, but not a measured interval, like chapter of books or the months. Actually, months, in some way, they behave as ordinal data. And we have intervals or ratio. They assume that they're equal distance by any two adjacent values, no? And we can have arbitrary reference points like the 0 or other references, and as I showed you in that graph, in the violin graph, in the hourglass graph of the pandemic that is showing us. The important thing is that we can do some transformations, and usually we can transform quantitative data into qualitative data. The other way around is not possible. And we can change ordinal rankings and make them categorical labels. Then basically we can go from ratio to nominal, but we cannot do the inverse operation. And that's something that we need to be aware, and that's one of the reasons why we prefer the more granular data that we can have, the better, because you can do the transformation in the direction from quantitative to qualitative, but not backwards. Then this is the second element, or the second dimension of the typology of the data visualization literacy framework. Then we need to understand the needs or the tasks. We need to understand the data scales, and we need to be aware of them and what are the type of operation and the meaning of them. The third dimension is the analysis. And what the framework tells us is that most data sets need some kind of analysis or some kind of transformation before we can visualize them. And there are different types of analysis that are commonly used in the pre-processing or modeling the data before we visualize that. Then when we are sorting ranking, that's basically a statistic analysis, or we can have frequency analysis, we can have mean analysis. Yes, but that's going to help us to create some kind of order or rank. We can do some temporal analysis, and it's when we are asking questions of when something happened, then we need to take into account time. But if the question is about where, we need to incorporate the geospatial analysis. Now, if we want to answer what, maybe we need a topical analysis or use that nominal and ordinal categories and classify things. And if we want to answer questions with whom or what are the relationship, then we need to do some kind of relationship analysis. Then this is a really high level of thinking, but as you see is when, where, what, whom, and how much, no? Are going to be those dimensions. Then we have statistical, temporal, geospatial, topical, or relationship analysis that we can conduct, or the type of questions that we can do with the visualization. Now, if you remember, we have data and we have data scales, and those data scales can be mapped to actually marks or representations, and then we kind of introduce some of those mappings, and we have tables, charts, maps, tree maps, network visualizations, and they are going to have different functions, and we have already presented some of those concepts that depending of that scale, depending of the type of data and the type of question, then we are going to have a different mapping. But definitely people have difficulties reading most of visualization times, and that's a reality. And the time required to read a visual images increases systematically with the distance between the initial focus point and the target. And that's independent of the amount of material. Okay? And look that these are studies really all. And what does it mean? Is the way that you present the data is going to influence the result. And for example, if we go here, UK is going to be really easily accessible, but elements here in the center, they take more time to actually access, and compare UK with United States, that are opposites, is going to be more complex than comparing UK with Armenia, for example, because the distance, the physical distance, is going to affect the way that we can process or understand the data. Then it's important to consider that how we distribute that, and that's how they are created a theory of graphic comprehension. Then we are going to study this a little bit more in depth, but for example, line graphs facilitate the extraction of information in those XY relationships, and bar graphs are easy the comparison between graphical elements that are in close proximity with each other. And that's the reason why there are some recommendations. What is better for what type of data? What is better for some type of questions? Just based on those research. And that's the way that we inform when to use something or something different. But that's something that we need to be aware, that the visualization, table, charts, graph, map, tree, network, they have their own restrictions, they have their own purpose, and depending then of the need, depending on the scale, or depending on the type of analysis, is the way that we are going to be choosing them. And be aware that there is no relationship in linear one. This is just dimensions that we need to take into account, and every single element can be connected with the other one in multiple ways, and the complexity is huge. Then when we talk about those graphic symbols, when we talk about the marks that we introduced the other day, the framework distinguish three different classes of graphic symbols. It talks about geometric symbols, it talks about linguistic symbols, and it talks about pictorial symbols. Geometric symbols are basic forms like point, lines, area, surface, volume, things that they are mapped to the physical world. Linguistic symbols are those that are constructed by human beings, like text, numerals, punctuation marks. Those have meaning and they are usually cultural dependent. And pictorial symbols are images, icons, glyphs that are representations of those things that are physically present in the world and we can see. In a way to see this is this table where we have geometric symbols like point or line, or we can have other other elements, because we can have also the area is going to be another symbol, but the primitives are going to be the point and the line. We have linguistic symbols and we have pictorial symbols. And here we are going to revisit these, but these are the three types of basic symbols. As you see, we are going to have different variables of that symbol that is going to allow us to better represent some functions. And those graphic variables are the attributes that we can put into those graphic symbols, and they are going to change the meaning. They are also known as visual channels, and identifies different retinal variables. They can be shape, orientation, color, texture, value, and size. We have also magnitude channels. We can organize them in the space and based on those retinal variables. And those retinal variables are divided in more detail. We can say that the quantitative graphic variables like size or color, they can have different ordinary directions. They can be sequential, they can be divergent, they can be cyclic. And quantitative graphic variables as motions, it could be bended to encode other data variables. And remember when we were looking into bubble graphs that are expanding on time, then that is going to give us the illusion of the speed of growth. And we can combine different type of graphic variables. Then let's go back to the chart, and then we can see that, for example, a point can help us to represent position in a plane, and a line also is going to have a position in the space. But text is really difficult to represent a space unless it's associated with a mark, because we can have a mark and then we can reinterpret the mark with text and reinforce the value, for example, and use the value that that mark is representing and use a linguistic symbol to highlight the value. Or we can have pictorial symbols that are going to represent the position in a plane or a map, and like a pinpoint or a location, or different conventions that we can use in a map to represent. Then the form size is going to convey a meaning, and you see that easily this circle is less quantity than this circle, and then we have a quantitative meaning. Or the same in lines, no? A thicker line has more emphasis or more represents more, a higher quantity than the smaller line. Or the size of text, and we have seen this, the size of text in the word clouds. The most common text in a collection is going to occupy more volume, And we can have pictorial symbols that are going to change in size, representing magnitudes. Shape is not that good to represent magnitude, but it's really good to represent categories. Then that point can be transformed in other geometric symbols or primitives, and then we can have now different categories that are encoded in the different shapes. And the same apply for line, because we can have different dash patterns, and then they are going to be telling us, oh, there are different things there. And in linguistic symbols, we can use different font types, for example, to make that emphasis or that distinction, or the text itself can just be the description. And in pictorial symbols, we can have different representation and create different categories just using variations of them. Now, when we incorporate color, we need to be aware that color has basically three variables itself. We have the value, then how much white or how much black we have, and that's that gradient that we can create. And usually the darker in value, the more density or the higher value we represent, and you can see that we can apply that for different graphical elements. Now, when we are talking about the hue, it's not good to represent value, but it's good to represent a scale, but it's good to represent classes. And then separating things by classes, the red, the green, or the blue, it allows us to distinguish, oh, there are different groups and they belong in different way, or create those clusters or represent different reference models. And now saturation is similar to the value, but is based on the variances of the same hue and changing the value of the saturation that is going to represent also density or value. We can also have texture, and the granularity is going to give us some information. As you see, there are more numbers per area, there are less number per area, and they are telling us there is something different, no? Or this is in lines, a solid to a more sparse. We can use the symbolic, the linguistic symbols also in that way, and change the granularity of the representation, of the pictorial representation, in order to create different patterns. And they are going to be activating our retina in different ways, and they are going to give us different understandings. And also, the pattern by itself, the way that we organize, is going to tell us different things, because we have just dots, and in certain order we have a different experience than the same dots in a different order, or the lines, vertical, crossing, diagonal. The same apply for using different symbolic linguistic symbols or different pictorial symbols. We can create different patterns and different experiences. We can also use the blurring, and that's another way of conveying information. And the sharpers or the blurrers then is a way to create gradients or create variability. And in motion, when we have animation, speed of growth or movement or representation is going to convey information, and we have seen that in the animations. Then, when we were talking about those variables of the color, and we were saying that they can be sequential, divergent, or cyclic, we were talking about this. That if we want to create categories, then maybe we just use distinct colors from different places from the color spectrum. But we can represent a sequence, and a sequence, when we are using the density or the saturation of the value of a particular hue, we can represent that. But we can also use contrasting elements in the color wheel in order to have that diverging effect. And then here we are playing both with the hue, and we are playing also with the saturation or the value. Or we can have cyclic representations that are helping us to just reuse some data. But depending of what you want to say is the type of variable that you incorporate. I'm sorry. Then we already talked a little bit about this, but the graphic symbols and the variables, when we combine them, position, size, orientation, color, luminance, we can support different insights or different needs. Then, for example, position can help us to identify outliers, and we showed that in the bubble graph that we have, because we can see a cluster here, and this one is definitely an outlier, and that happened in that bubble graph we have. We can identify trends through position. We can see that yes, there is a tendency there, and we can identify clustering by position because there is separation there. But if we want to represent outliers, we can use size. You see that we have variable sizes here, but this definitely is different than the other ones. Then it's really easy to see that outlier. Or we can see the transition, how the size increases with some variable that apparently is in the X and Y, and there is a relationship in that way, and we can see that tendency that something is growing. Or we can see clustering depending how we organize the data, and see that the small ones are together in some way, and the medium ones are together, and the big ones are coming together. Or we can use the color to represent the same thing, and we can see, this one is in the middle here, is kind of different, the other ones are intermixed. Or we can see a trend because we see the gradient of transformation, or we can see clear clusterings and separation using colors. Then visuals and the different variables, then as you see, they can support different insights. And this is just an example. We have multiple insights, and remember that then all this can be mixed in different ways. Now, interactions is the last dimension, but not least, that we have in the framework. We already talked about the static visualization, like printed on paper, but others that can be manipulated dynamically and create different types of interactions. And we introduce some of those interactions, like zooming, filtering, doing some highlighting, and these different interactions. Then we saw a typology. This paper presents a different typology, but you are going to see that is not in opposition to the one that we have studied. And in this typology, they have two basic tasks. One is why, and the other one is how. Then the first Y is Y% discover, enjoy, produce, search, look up, browse, locate, explore, and query, identify, compare, and summarize. Yes, you are looking for some meaning, and you are trying to establish just that value and look for that value and understand why. Now, how consists of encode, manipulate, select, navigate, arrange, change, filter, aggregate, and introduce, that contains annotate, import, derive, and record. Then this is more like the cause effect, and this is more about the basic exploration. Then this typology focus on the flexible and interactive use of visualizations, and it names basically 12 different actions in 3 high-level categories. Then we can have data and view specifications, visualize, filter, sort, and derive, view, select, manage, coordinate, organize, and process or provenance like record, annotate, share, and guide. And you can see that we can map this with the previous things that we have studied, and it's just another interpretation of the word, and in that way we complete the different interactions, the different typology of the data visualization. But where is this coming from, and how we can use actually this in practical way? Then that allows us to introduce a concept that is the cognitive task analysis. This is a model of how we interact with the world, basically. Then we have an individual that has some needs. Then it has a foraging loop, or a seeking information, searching and filtering, extracting information, and it has another loop that is making sense. Then when we have a need, we want to acquire, and to acquire we use the data scales. Then we look into that data and we conduct some kind of analysis. Then that's the way that we map this into the framework. Now we have the visualization, and when we have the visualization, then we have the mapping, and we have the graphic symbols and how they are able to create meaning and allow us to interact. And once we interact, then we interpret what we are seeing, we translate, and we have conclusion. Then this is basically the cognitive task analysis, or the articulatory loop that we have there when we are doing a visualization. Then I said already, the stakeholders identify their needs. It could be verbal or textual description of the problem, and usually we formulate that into a data visualization problem. And then we need to use the appropriate data sets, we need to use the proper analysis and the proper visualizations and workflows in order to be able to deploy something that is going to be useful. When we're thinking about the acquisition, then we need to be aware that the relevant data sets and the relevant sources are used, because if not, we are going to be creating some biases. For the analysis, then we need to clean the data, we need to do the data transformation that we might necessarily, and then we need to think, hey, is there going to be a statistical and temporal, geospatial, and topical, or relationship analysis? What type of questions do we have? Is this when, where, what, with whom? And then those are going to be informing us. Then now, when we visualize, we need to pick the reference system or map, and then we design the overlay, basically taking into account the visualization types, the typology that we already. So I'm thinking about what are the insights and how we need to map these things in order to answer those questions. Then we deploy that, and we can deploy that depending of different of the human user interface and metaphors that we have. We can deploy that printing, we can deploy that in the computer, or we can have different ways of representing visualization. They can be physical objects that we can create to deploy that data. And we need to be aware how we want to interact and provide different alternatives and different ways of interactivity that we already introduced those concepts. Then in the interpretation side, we need to be sure that the we translate those visualization results into those needs and telling stories that make difference in that observer. And then we are going to be studying how to tell stories in the future. And this process is cyclical because we need to evaluate, are we really conveying what we want? And then we revisit the thing, and maybe we need to change the data scale or the data set, or we need to change the analysis, or we need to change the visualization or the interaction if we are not getting that. But how we know if the data visualization is working? Then we have methods to assess that. Different researchers has proposed different methods to assess visualization literacy, and they try to understand how the public comprehend data visualizations. I already introduced you that the results are not that promising, and this is also various ways of learning unfamiliar visualizations to improve the literacy. Then let's talk a little bit about measuring comprehension. When we want to measure a graph comprehension, is basically how we measure how people read and interpret a graph. And it has 3 levels. When we ask the user to read a specific value, the second level is when we ask the user to read relationships in a graph. And the third level is when the users can go beyond what is presented. And I already did a little of exercise when I was presenting you the graphs about specific values, about the relationships, and trying to extrapolate behaviors and future. Then we can see this like read the data, read between the data, and read beyond the data. Also, there are ways to understand the graphic comprehension level using open-ended questions, like what is the most important information on the graph? And this provides really detailed descriptions about individual comprehension on individuals comprehension of the graph, and are going to be useful to examine those insights from that data visualization. And some examples of visual literalization assessment is we present this graph to the user and we can ask, does this type of data presentation look at all familiar? Oh yes, no, and how it comes? Where might you have seen these images like this? How do you think you read this type of data presentation? And now we can introduce, okay, tell us more about what you are seeing there. And then we can explore things like if the title is accurate, if the sorting is proper, if the labeling is proper, how we are confusing the people with total cases versus new cases, and what is going on here, and what is the expectations, and if they want to see USA. And anyway, then open-ended questions are going to help us to understand what the people is doing. And there are formal ways of evaluating that. Then the visualization literacy assessment test, it has 12 data visualizations and it has 53 test items that basically covered 8 major tasks. And then they took the tasks are these: then retrieve a value, find an extremum, determine a range, characterize a distribution, find anomalies, find clusters, find correlation trends, make comparisons. And then we have here the chart, the bar, the stack bar, this 100% stack bar, the pie chart, the histogram, the scatter plot, the area chart, the stack area, the bubble chart, the choropleth, and the tree map. Now you can see a little bit of the type of data set that we can represent in those visualizations, and what kind of results they have, which visualizations can be done better with one or other kind. As you see, a scatter plot is kind of neat way of presenting data, because we can do a lot of operations. And maybe that's why I'm biased to those bubble graphs that are scatter plot with variable size and color in the marks, because they are quite flexible, and when you have that animation over time, they are fantastic. No? And then you see here the bubble chart, that is the spatialization of the scatter plot. But doesn't mean that you always want to have a bubble chart. Interpret a bubble chart. That is and the animation requires really understanding of that visualization. Not everybody is familiar with that, and they are not able to read that. And sometimes we need to reduce the complexity and come back to histograms or lines or chart bars, or depending of the function there. And be aware there are some limitations here. These are the different visualizations that they use for the evaluation. And then they incorporate something that is the item response theory, and this helps people to assess the level of literacy with a set of tests. And I say that they already have different tests, 53 tests to be conducted with those graphs. And this is a psychometric, this is derived from the psychometric test theory, and help us to understand item analysis. Then the question that they wanted to understand is what percentage of people correctly comprehend certain types of data visualization. Okay, and for that, then they use the item response theory, and it allows to calculate the probability of a person answer a test item correctly based on the person's ability and the item's difficulty. Then this is the mathematical formula. Then we have the response versus the background and the difficulty of the challenge. Then they use this to apply for the different task, and then they calculate and provide this graph. And when we look into this graph, then we have different items and the different tasks. And if you see in green are things that are preferable to do with graphs. Then, for example, if you want to retrieve a value, like what is the price of a barrel of oil in February 2015, it's highly probable that somebody is going to be able to retrieve that from a line graph. And if you see the higher score, we don't have the same question, but we can ask the same question in different other places. But definitely retrieve value is 95, retrieve value is 88, retrieve value is really low here. Then it's telling us that maybe that's the best representation for retrieving values. And if we want to find an extremum, we have 97 here, we have 98 here, The pie chart in relative value does a really good job as well when we are using proportions. And stacked area chart is useful for finding extremum as well when we have that, and the choropleth in the intensity. Then now it goes back, what is the insight, what is the type of data that we want to do, and you can just use this table. I'm not going to go into the detail, but you can see the different tasks in the different graphs, and you can see what the graph is better for. Then line charts are really good for values, extremum, and correlations. Bar charts are really good in finding extremums and retrieving a value. The stacked bar are really good to relative values and extremums. Pie charts in relative values. Histograms are really good for finding extremums and make comparisons. Scatter plot is really good to find their clusters, and maybe the first application that we want. Area chart are really good to finding correlation of trends. The stack area chart is really good in finding extremos and correlations and trends. The bubble chart, you see, is really difficult to use. Even though it conveys a lot of information, you need to be trained to use the bubble chart. Then even though it's able to support a lot of the functions, still difficult to use. The choropleth, really good to comparisons and extremums, and the tree map, it's really good for hierarchies. Then this is the probability of success. The first column is the probability of success, and this is the intrinsic difficulty of the task in the environment. Then yes, the tasks are relatively easy, but people once you know how to do them, but the probability of somebody being successful is problematic. Then as I said, I am biased towards this, but I understand also the limitation of the graph. Then that's why we need to be aware. We already presented this previous class. Then definitely we need to reach out to users, and this is going to help us to understand the level of visualization literacy. Is help us to understand and know the strengths and weakness that our public is having when we are presenting data, and to understand that basically the individual strengths and weakness in reading and interpreting data are going to be related with the literacy, the education, and training. Therefore, we need to plan ahead. I want to introduce here a particular visual representation, that is the information graphics or the infographics. Just to think about it, we will revisit this in the future, but when we are talking about infographics, is when we use visualization to present ideas and try to convey complex information and an audience that they can quickly consume and understand that. And they use data that try to create information and knowledge, and they have a wide ranging applications. It could be used for news dissemination, scientific visualization. It can be used for product design, education, information technology, and you name it. This is an example of infographic about diabetes, and you see that we can combine visualizations. We're using contrast, we are using text, but we are using also the symbols, and the symbols are representing a meaning. We are using colors, we are using shapes. in different ways that provide us additional insights. Then I just wanted to introduce the concept of the infographics as an extension of visualization. And at the end, we need to investigate the user's ability more about how they understand and how they use the planning tools in order to conduct the task, and using given visualization tools. This is maybe one of these initial research, the one that I present, but we still need to do more things because there are other tasks, new visualization, new interfaces that we haven't explored deeply. We need also to understand the perceptual skills in how people detect patterns and what are the different cognitive skills when we have a series of tasks, no? When they are analyzing data or getting insights or generating new knowledge, because as you saw, we only have a simple task, but there is an opportunity there to understand what is going on. And we definitely need to ask ourselves, do users fully understand a given visualization tools that they provide them when they want to solve a problem, on how they deal with the roadblocks, what are the type of shortcuts or ways that people use to overcome those shortcuts. I hope then that this has been informative. You have additional material that I invite you to review, and hope to see you in the interactive session. Thank you very much and have a good one.